Welcome back, students. Still working normal models. We're in lesson 12. We're up to video E. Log on to StatCrunch. Most of the videos, in fact everything but normal models, we'll usually do formula based in the notes. Practice with StatCrunch in class. But for normal models, there's really no way around it, so we'll have to use StatCrunch to do this part here. So for videos E and F, make sure that you're logged on. Pause the video when you need to. Make sure you're getting the clicks. Of course, we'll practice in class, but we'd like to get a nice groundwork for you at home. And it's not hard. It's an easy tool to use. Okay. So why do we need StatCrunch? Most times when we're solving normal model problems, the values we're interested in are not going to fall exactly 1, 2, or 3 standard deviations away from the mean. When they do, we can approximate with that empirical rule. But in the real world, this won't happen. So that 68, 95, 99.7 empirical rule is not going to be sufficient. Okay, so fire up StatCrunch. I'm going to kill the lights here. And if you log on to StatCrunch, make sure that you're logged in. All we'll do here is we'll just open up a blank worksheet. If you go to the group page, you can always open up any of the worksheets that we've used in class. But here's Open StatCrunch, and this will give us a blank worksheet. Now, we're working with the normal model calculator, so there's no data. This will just stay blank. And where do you find this? It's up in the Stat menu, Calculators, and then Normal. Okay, so those are the 3 clicks that we'll do. What I'll do is just talk us through it, and I'll show you the steps on the screen, and then I'll probably write a little summary remark each time. So, Stat, Calculators, Normal Model. We're going to look at that first example in 12E, so we're going to use the IQ Normal Model. So the whole time, I think I can just sort of squeeze it up here. This is the normal model with the mean of 100 and a standard deviation of 15. So we're looking at IQ scores. All right. Part A on the page with video 12E. There are many ways to essentially ask the same question, so I'll give you a couple ways. One way I could ask the question, give the probability that a randomly selected person has an IQ exceeding 120. Another way to say it is what percentage of the population has IQs above 120, what fraction of the population, what proportion of the population. All of those questions are telling us to shade under the normal model from 120 and up. Okay, so that's the task. We've got the normal model calculator open. You can see that the default is the standard normal model. It says mean of 0. What we need to do is change that to 100 because we're working with IQ scores. And we need to change standard deviation up to 15. Okay. And what the calculator does is I'm going to tell it where to shade, and then it'll shade it and tell me the percentage of area under that normal curve. The value that we're interested in for this question, it says what's the probability that somebody has an IQ exceeding 120. So down here, probability X, the default's less than equal to 120. I need to jump in the little drop-down menu here and do greater than. And so make sure you've got all the boxes correct. We've got a mean of 100, standard deviation 15, and probability X is greater than equal to 120. It put the answer right away. I guess you hit compute, it's not going to change it, right? So we've got a 0.0912. Answer's down here in the left box. And so if I just write, there's a 9.12% chance that someone, randomly selected person, has an IQ of 120 or up, right? You could put a plus there or greater, or however you want to say it. That area shaded corresponds to either the probability, a randomly selected person, or if you said, how about the general population, what percentage of all people are up there, 120? Okay, so 2 interpretations of that. All right, pretty easy, right? I mean, it's the inventors of StatCrunch have made this as user-friendly as possible, I think. Down at the bottom, that's about it for that page. So if we flip over to part B, looks like on the next page, we will go again. All right, so here comes B. There we go. Keep us focused here. There's part B. What is the probability that someone in Maryland has an IQ of at most 80? All right, so we're doing probabilities. Probabilities correspond to shaded areas. At most means 80 or below. So I'm going to just put the words here. Right, at most 80 is the same thing as 80 or below. You've got to get those words translated correctly into the correct direction. Mean IQ is 100, standard deviation is 50. We're going to take this 120 and we'll switch it to 80. We will go to less than, and the answer did pop up automatically on mine. You might have to hit compute there. Notice we get the same answer. The normal model is symmetric, so right here, right, there's that 100. I went 20 up and shaded, I got that 9.12%. If I go 20 IQ points down and I'm shading from 80 and below, I do get the same answer here. So I'll circle it again. Question says, what's the probability that someone has an IQ of at most 80? Right. You can write that as a decimal, 0.0912. You can write that as a percentage, it's 9.12%. And that is the percentage of the whole that's shaded, the red stuff there on the tool. Okay, so that's 9% of the whole graph, which would be 100% or 1. All right, pretty easy tool to use. Ideas are pretty clear. All right, part C then. Let me make some room. And I'll read the question at the bottom of the page, part C. What percentage of the population have IQ scores that are at least 3.5 standard deviations above the mean? And it says to use StatCrunch. All right, so let me just make myself a little bit of white space here. And I'll write some notes and then I'll erase it. I want to go 3.5 standard deviations above the mean. And so really think about that. If I have the normal model, it's centered at the mean. I want to jump up 3.5 actually, right? So I'm going to go mu for the mean plus 3.5 times the standard deviation. And so that's a z-score of 3.5. I want to go 100. I want to go plus 3.5 times 15. Maybe some equal signs here. And so 3.5 times 15 is going to be, oh, I don't know, I'm sure I have it written down here. That's 52.5 points. So this is 100 plus 52.5. Pretty high IQ, right? And so that's the number that we need. We sort of had to do a little bit of work before we went to the tool. 100 plus 52.5, 152.5. And what percentage of the population have IQ scores that are at least 3.5 standard deviations? So that's the number that we need. I'll erase it. We'll go to the StatCrunch tool and we'll get the answer. Clean that up. Remember where it is, stat button, calculators, down to normal. And we're still working with IQs. I put the mean for 100. I put standard deviation for 15. We're doing greater than. Right? Read the question. What percentage of the population have IQs that are at least? At least means greater than. 152.5. So we'll do greater than 152.5. I hit calculate. And, well, you can see the graph only goes to 140 plus a little bit more. Nothing's shaded in red that you can at least see on the screen, but this is the correct answer. Somewhere out here is 152.5, and it's shading that little itty bitty piece there. The number I have here is 0.0912. we've got 3 zeros and then a 2. I mean, you could put the 232 if you like, but I'll just round it to 0.002. That is quite unusual. This is 2. This is a 2 in 10, 100, 1,000, 2 in 10,000 chance. This is a 1 in 5,000 chance. And so it's quite rare, right? We're more than 3 standard. We're 3.5 standard deviations above the mean. And that's pretty darn rare. To be 3.5 standard deviations is only 1 in 5,000 chance. Okay, so hopefully everything's fitting together. We have z-scores, we have normal models, we have probabilities. Quite unusual, and there's your answer as a decimal 0.0002. Okay, so let's see here. The next one, you'll flip the page, let me clean up the board. Now we're going to give you the ideas here in a second, but in between the time when the notes were written, StatCrunch gave us a little update, which might make in-betweeners just a little bit easier. You can see at the top, when I have the normal model tool open, I have standard, and then there's this in-between button. So what's the idea here? I'll draw a little example picture. What if I'd like to know the percentage of people with IQs, say from 80 up to 140? 80 to 140, the trick is you would shade from 80 up to 140, and if you could find that area, then that area would correspond with that probability. Now, before, there was no in-between button, so in the notes you can see that I sort of have to piece it together, and I'll demonstrate that. But of course, if you've got the trick, you can do the in-between, then everybody will use the in-between button. Okay, so let me show you what was happening in the notes. And it should help us understand normal models and probabilities, and that everything does need to add up to 100%. All right, so part D, top of the in-betweener page, give the probability that an IQ is between 100 and 125. All right, so what do we do? And maybe I'll write, we've got probability 100 less than equal x less than equal 125. All right, so here's what we did in the notes, and I'll just sort of read it out. Because StatCrunch will not compute an in-betweener, well, it will, under a normal model, we can use the following logic. Find the area to the left of the left boundary, find the area to the right of the right boundary, and subtract those off, and you'll be left with the middle stuff. So here was the idea. There's 100. If I can find this area here, everything to the left of 100, I can use the less than button. We wanted to go up to 125. 125 is about here. I find all of that area there. And if I take 100% and I subtract off this stuff, and I subtract off this stuff, then I will be left with the little sliver in between. And that was a 3-step process. And so then somebody at StatCrunch said, well, why don't we just invent the in-betweener tool? And so that's how we'll do it. All right, I'm going to do it the long way once, and then after that we'll do in-betweeners the easy way. So in the notes, let's see what we've got here. I'm going to switch back to standard method. The mean's 100, standard deviation is 15, and then what I'll do is this part first, colored in red. So we can find the area to the left of 100, it's shaded in red, and that's half, it's the bottom half of the data. So this is 50% or 0.5, that piece right there, okay? Now I can find the piece up in the upper tail, so it's going to come in here somewhere, right? And I will just switch StatCrunch tool. I'll do probability x is now greater than 125. And now the piece in red is up here. There's the answer. It's about a 0.04779, blah, blah, blah. I rounded that to 0.478 in the notes. Okay? And so if it has to add up to 1 or 100%, you just take 1 total, subtract off the stuff in the left tail, minus 0.5. Subtract off the stuff in the right tail, minus 0.0478. And you'll be left with the piece labeled with the X. Definitely the longer way to do it. So the area in between, that's about 4522. 0.4522. And so we could interpret that as there's a 45.22% chance that anybody selected at random has an IQ in between those two boundaries. All right. So if you like driving yourself crazy with the hard way, there it is. I will always do the easy way because life is short. We don't want to be subtracting things we don't have to. And so let's just verify, do we get the same answer? I sure hope that we do. Same question. I switched it in between. The mean's 100, the standard deviation is 15. I would like to go from 100 up to 125. And you should test before you make a video to see if you get the same answer. But what the heck? 4522. I sure hope we said that before. I think we did. You can see it shaded it. This is very intuitive. It makes sense, right? And so that red stuff shaded is about 45.22%. All right, I'll make one comment here, and then we'll quickly go through the practice ones at the bottom. You need to be able to draw these on paper. We're going to use StatCrunch to arrive at the answer, but make sure you can still draw a normal model and shade appropriately. Okay, we don't want to become 100% reliable on technology for understanding the ideas. It's a tool, but we need to have that understanding. All right, so quickly we'll do E, F, G, and H down at the bottom. You should practice these, build some confidence, make sure that we can arrive at the correct answers. I'll go fairly quickly because I know you can pause it. What percentage of people have IQs between 80 and 90? Between, that's easy. We do an in-betweener. Oops, changing the mean there. Mean's 100. I want to go from 80 up to 90. Notice the picture. The picture is shaded. You need to be able to shade. Notice the picture is labeled and percentage corresponds to area. In-betweener. I got a 1613 or 16.3%. Based on the model, people have IQs between 80 and 90. Right. Move on to F. F. What's the probability that the person sitting next to you in class has an IQ of at most 95? Probability at most 95. At most, at most, at most. At most 95. That's 95 or below. That's 95 or below, students. So we're shading left, left tail. Standard, not between, standard. IQ for the whole example, change to less than equal to, I think it was 95, right? Yep. Hit compute. There's 95 on the graph. I'm shading to the left. And all that area corresponds to what's the chance that your IQ is at most 95. Maybe you want to write it formally. You would put probability X less than equal 95 equals, about 369. 0.369. Right? These are easy to do. They're satisfying. We get the right answer. Too many problems. And of course, we're using IQ every example, but if I was doing heights, I would just change the mean to whatever the mean is and the standard deviation. Okay? Don't lock in on 115 here. 2 more to go. What proportion, part G, what proportion of Cecil College students with IQs greater than 150? Proportion greater than 150. All right, we're presuming this IQ model is good for Cecil College or Cecil County students. 150 looks to be in the upper tail. Problem says greater than, so this is pretty easy, right? Mean of 100, standard deviation 15, probability x greater than 150 is, oh, not too big, right? There isn't even any shading. I mean, 150, I guess, would be here somewhere. I'm shading that stuff to the right of 150. Here's your answer. Looks like it's a 0.12. 3 zeros and a 4. Right? How about as a percentage? It's 0.04%. It looks like about 4 in what? 4 in 10,000, so very, very rare. Proportion of Cecil College students with IQs greater than 150. All right, part H, last one, and then we'll call it a video here. If there are 2,500 students at Cecil College, how many do we expect to have IQs of at least 150? Well, we don't use the normal model calculator this time. Let me erase this. Let me move that out of the way. I see in my notes I did a little bit more accuracy. I did take this out to 0.00429. It's here. And this is an easy question. Don't fool yourself. 2,500 students, I expect that percentage, or this decimal here, to have IQs of at least 150. I just multiply, right? I take 2,500, I multiply that times 0.00429, and if you do that, less than a handful, right? This comes out to 1.0725 students. Oh, so maybe 1, right? If you had to round this, I guess we would expect one student on campus to have an IQ of at least 150. So it's pretty rare to be that far up. Looks like about 2-point-something standard deviations. All right, so practice with this. You'll use it for the rest of the semester. Kim Shepard will come back on the next video and show you how to do backwards problems. So, thanks for watching. We'll see you in class.